right, so constant multiple rule for differentiation. This follows, remember, derivatives are limits, and this follows directly from the constant multiple rule for limits. The limit of a constant times a function is just the constant times the derivative of the function, right? So if c is a constant, if c is just a number, how about and f is differentiable, then the derivative of that constant times f is just the constant times the derivative of x, of f of x, sorry. All right. Maybe we write in English the derivative of what? A constant times a function. I'm writing a little too big. Is just the constant times the derivative of the function. How about we write in math? It's just the constant times the derivative of the function. Okay? So example 3. Write the equation of the tangent line to this curve, f of x is equal to 2/3 x cubed, when x is 3, and then go ahead and sketch the tangent line. So to write the equation of the tangent line, you need two things. You need a point and a slope. And I recommend going after the point first, simply because sometimes when students take the derivative, they accidentally find a point on the derivative curve. And so let's just do the point first. Step 1, find the point of tangent C. If you like your point slope form, I'm looking for x1, y1. And we're looking for this when x is 3. We're looking for 3, comma, go find f of 3. And since I haven't bothered calculating a derivative yet, I'm not going to plug into the wrong place, right? F of x is 2/3 x cubed. So f of 3 is 2/3 times 3 cubed, right? That's 2/3 times 3 times 3 times 3. There's a times 1. It's just 2 times 3 times 3. It's 2 times 9, which is 18. Okay? So here's your point of tangency. Your x1, y1 is 3, comma, 18. Just put a 3 in everywhere I saw an x. And the y coordinate ended up being 18. Okay? Step 2, find the slope at that point. We need to calculate the derivative. Find m. Remember, the slope is the derivative, and let's find the derivative anywhere, and then specifically plug in what? 3. Plugging in that x value will give me the slope of the tangent line to the black curve, to 2/3 x cubed at the point 3, 18. Right? So here's your f of x, 2/3 x cubed. It is a constant times a function of x. I'm using my constant multiple rule. In fact, I'm going to emphasize it by using the orange, right? The derivative of a constant times a function is just the constant times the derivative of the function. So f prime of x is just the 2/3 times, now I get to think about what the derivative of x cubed is. Ah, I love it, power rule. It's 3x squared. Just simplifying that algebra, 2/3 times 3 is just 2. So f prime of x is 2x squared. This function, given any x in the domain, it'll spit out the slope of the tangent line to this function. I want the slope when x is 3. So I'm going to go ahead and plug in 3. So your slope is 3 squared, which is 9, times 2. Your slope is also 18. Putting this all together, right? Write the equation. Of the tangent line. Y minus y1 is the slope times x minus x1. My point of tangency was 318, if I remember correctly. Yeah? x1 is 3, y1 is 18. So y minus 18 is equal to my slope times x minus 3. And from step 2, we figured out what that slope was. That slope is 18. All right, now we're just going to do a sketch. So my point of tangency was 318. 318. Right here is the curve f that's graphed. Is the 2/3 x cubed. That's a 3. Right, that was my function, 2/3 x cubed. And does it seem like the slope of the tangent line here is 18? A slope of 18 is 18 over 1, right? That's up 18 and to the right 1. I'm counting by 3s here, right? This my scale to make this look okay. 3, 6, 9, 12, 15, 18, up 18 to the right, that whole distance is 1. This is not a point on the curve, right? This is a point on the tangent line. That's also the same as down 18 to the left 1. So here we go, down 18 to the left 1. Does this look like it's the tangent line? It does, if your teacher could draw well. No, I can draw well. Growth mindset. Boom. There's your tangent line. And its slope is 18. Seems believable. I encourage you, like I did on the video before, maybe go and play around on Desmos and convince yourself that this isn't looking like it's right. I know this is exactly right. All right. Thank you for watching. In the next video, we will be doing sum and difference rule.